No problem. We're on to day 15 now. Ooh, lanternfish. That is definitely a throwback, alright. So it looks like we have a grid and then a bunch of arrows. We'll explore what that means in a sec. They have a map of the warehouse and a list of movements. Okay, so the robot will try to move. If it will move into a wall, it fails. Cool, so push a bunch of stuff around and eventually finish. And they have a GPS system. The lanternfish would like to know the sum of all GPSs. Okay. Cool. Yeah, this is probably complicated enough. I'm going to start with the example rather than starting with the main one. Obviously, I will eventually use the main one. But I think day 15 is honestly quite an interesting point. 1 second. Yeah, sorry, it's an interesting point, I think, because this is generally what I think of as the dividing line. What I mean by that is I feel like generally the early days, aka 1 through 15, are relatively simple, and I'm pretty confident I can solve them. You know, at least I have an idea for how to solve them, even if I don't actually solve them. And then the next days tend to be much harder. Actually, I think famously day 16 is often very difficult. Day 19 I think was also quite hard one year. I can't remember if it was last year or the year before that. Sure, there's a lot of movements. Okay. Okay, so now we have a bunch of lines. We can go build our grid. How do we want to build this grid, actually? Okay, just kidding. Let's do a... I don't know if we want to do... What do we want to do here? Let's build this grid manually. The issue is there's not an easy lambda to convert this into numbers, because there's like 4 different objects. If it was just one object, I think it'd be fine. But the fact that there's 4 makes it a bit trickier. I could just do some character manipulation, but this is relatively fast, and I'd rather not have a bunch of numbers I don't really know, because that sort of comes with its own problems. Okay, so let's see what we want to do. Now, I could use a switch statement here, but I'm gonna not use it in this case. No real reason, I just don't remember the switch syntax in the moment, so not gonna bother looking it up, just going to go with it. So at symbol is the robot, coordinate robot equals new coordinate. I'll start at 0, 0, and then we'll do robot equals... Okay, that gets the robot in the right spot. And then we want it to be the same as the floor. Let's have this be 1 maybe. We'll have this then also be 1. We can have the walls be maybe 100 or 1,000. something that represents impassibility, I think, trying to think of as big numbers. And then the boxes can be 2, no real reason, just is the number after 1. Why does it not like this? Right, I never set the equals 1 part. Cool. So now I have the robot, and I have the grid. I need to now figure out how to deal with the movements. Okay, I suspect there's a reason they're not all on one line, which we'll probably find out later. So I'm just gonna assume that's significant and move this into a new thing. Again, generally don't optimize for that type of thing. I think predicting part 2 is not really worthwhile most of the time, but in this case, like, I don't think it's a big deal because it's so simple. Just add a Boolean flag. Okay, so now we have all the movements. I think then all we want to do, right, is do for what is it, char in all movements dot to char, right? We want to give it what, 1 cycle C robot grid. I think that's all we need. Cool. And then at the end, we're gonna want to do sort of this again. Except we only really care about the grid equals 2 case. Because I don't think we GPS locate the robot. Move all that. And do like answer plus equals 100 times x plus y. This might be 100 j plus I. We'll figure it out in a sec. That's not the most important detail, I think. Let's work on 1 cycle. So it'll need to take in some character where the robot currently is. I don't think the direction the robot faces matters here. And then the grid. Okay, cool. So now we want to do what? Which way is what? So we have left, right. Okay, so the 4 normal directions, that's fine. Ooh, okay. Let's just do 1, -1, 0, 0. I have to make sure I get my things right here. Let's see. So we do int direction equals 0. No, equals -1. Then if C is up, I want to copy this 4 times. For down, left, right and left. So left, I think I want to be direction 0 because, no, wait, that should be right because that's when x is 1, right? So direction equals 1 for left. So down, I think is actually positive j in our case. So direction equals 2, and then up would be negative. That might be wrong. We will see shortly, but now at least we have an idea. So, okay. So what's the plan? We want to ideally okay. So we can say the goal coordinate is basically where the robot is plus, the current direction of travel. And if it's empty, so if I guess if goal dot, how do I do this? If goal dot, yeah, I might take it out of bounds, right? Actually, no, it can never take it out of bounds because of the boundary. Okay, so actually we don't have to worry about that. Grid what do we want this to be? So if it's 1, then we're good. We just do robot equals, we are chilling. If it's 2, it's also quite simple. I really gotta turn this stuff into a switch statement later. Sorry, not 2. For it's 1000, it's actually also quite simple because it just directly return, right? And if we can't move into a wall. That's something that the tough part is if it's 2, right? That's where the logic goes into an interesting area. Oh, right. I can't do this. I would do robot.x equals goal.x. And then robot.y equals goal.y. Okay, so otherwise, now we know that there is a box in the way. So what do we do if there is a box? I think we go and see if there's ever an empty space. So Boolean sum empty equals false. We assume there's no empty space, and if we find one, we're good. So now we can do a just do while true. Okay, how do we do this while true? Basically, we want to continuously add until we find an empty space. So goal equals, I think we just basically keep moving it. This can be goal, this can be goal. Cool. So, and then we check again if it's this, then we break out of the while loop. Sum empty is still false because we hit a wall basically. However, if it's this, actually, yeah, we should have a coordinate to designate. First empty equals. Cool. So we have some first empty. Actually, I'm gonna do negative -1 because if it stays at -1, that's really bad. And this will break rather than failing silently, which I think is the worst case. So if it's 1, that means there's an empty space. So we actually want to record this empty space. Sum empty equals true. And then first empty equals new coordinate goal.x, y. Cool. So if there is an empty space, then I shouldn't have called this goal. That's fine. We want to set this to not empty. It is now a box. And then we want to set robot to this. Robot.x equals robot, actually plus equals x's direction, and then, right, because that means we can move. Otherwise, it means we can't move. In which case we're just done. So we don't actually need that case, because this is going to return anyway. Okay, so now we have at least the concept done. 18,208. No, that is very wrong. Okay, makes sense. But yeah, let's do this smaller example to start. I think this is probably a reasonable starting point. So this gets us, yep, okay. So what we want to do is actually also just print out what it looks like. Yeah, I think oh no, I can't just print out the numbers, unfortunately, because 1000 is obviously bigger than like 1 as a number. So I'm gonna do a little bit of hackiness here. We want to do But you see what I mean? Like, I generally know what I'm doing here. Now I'm not going to be very fast, nor will I like make the leaderboard or anything like that. But at least I think the concept is relative to us. And this one's pretty straightforward, just because it literally basically tells you each step exactly what to do. Like, oh, do this, do that. Yeah, and also just to confirm, the robot does not have a GPS location, right? Yeah, it's just the boxes. So the robot actually doesn't matter at all. Cool, let's print it out. So it's supposed to look like this at the end. No. This is the smaller example, sorry. So it should look like this at the end. Huh. That's a long chain of... Wait, that's crazy. The walls don't go in there, do they? Oh, it does go in. Huh, did not know there were walls out there. Okay. So this is kind of bad, given I see 4, 5, 6, 7, 8, 9. Oh, right, because the space the robot is should actually become a 1. Right now it's a 2. Yeah, I'm effectively just generating boxes out of thin air currently. That's bad. Okay, 2027. Still not right. It should be 2028. Interesting. Oh no, but it looks horrendously wrong, right? Okay, let's take this move by move then. Yeah, let's print out after every move. Now this is gonna make the input a lot bigger, but hopefully this... Oh, I should do another print line. Otherwise it just looks like one gigantic grid. Okay, so we start... Okay, let's do this. If I equal robot.x and j equal robot.y, then we instead print out the robot. Otherwise, we do all the other stuff. Okay, so the robot tries to move left, fails, moves up. Oh, no, I'm moving the wrong way. This is moving up. Okay, that's bad. So that means I should flip. Oh, wait, so this moved up when it was supposed to move left. So first coordinate left, this should be not 1, clearly. In fact, I think this should be 1. Okay, well, I have a strong suspect that the other two are flipped as well then. So let's just move those, see if that makes sense. Ooh, 2028, that seems good. Is it where it's supposed to be? It is, okay. So let's go back to this, to quick run, 10,092. That sounds reasonable. Yep, okay, now let's do an even bigger run. This is gonna be a lot of output. I should have turned that off. Where is the ability to turn that off? Boom. Rerun. Cool. Okay, maybe a bit too safe there. I could have maybe not done the other input check. Everything except the robot is twice as wide. Oh, interesting. Okay. This does not seem too bad. Align so that they can directly push 2 other boxes at once. Oh. Oh, that's interesting. Okay, well, so the first part is quite simple, right? We just need to edit the lines. do something like this. Then do for line and lines, for character in line. So for line and line, we first do new lines dot add this, right? And then we do new lines dot get last. It's not a thing. Okay. We do for loops then. Sorry. Yeah, non-enhanced for loops. Because apparently we need the index. Okay. So we can then do new lines that, and then for character in lines dot get, nope, dot get I dot to char array. We do new lines dot. Actually, we can just add it at the end. String new line equals. Again, I should probably use a string builder for that, but I'll be honest with you, I've never actually used a string builder on purpose. I think I've done it a few times, just because the IDE tells me to, but never really on purpose. Okay, again. So we want this. It's only width, right? Or does it? Yeah, okay. It doesn't double in height. Cool. So we do new line plus equals boom. It's actually very nice that it's width specifically. With height, it's actually kind of tricky. I'd have to do some nonsense. Okay, so now we have 4 of these cases. Wait, but the robot is not wider, right? Aha, okay, the robot is not wider, so we do not do double for the robot. We only do that for everything else. Oh, sure. Yeah, apparently it has, yeah, okay. That's good, actually representing the left and right side of the box. Cool. Okay, so now we do want to pass in, we probably want to pass in part 1 and then just delete this. There's nothing unique to part 1. There's only stuff unique to part 2, so there's no reason to do an if part 1. Cool. So we add a part 1 thing here. So the only moves, oh no, okay. Oh yeah, wait, the height isn't, it says left and right pushing should never change, right? Like, yeah, left and right should not change. But oh, I do want to actually designate them separately. So we'll have, what do we want left to be? Let's have left be 3, and then right can be 4. This is, yeah, it's a relatively simple looking part 2 for sure. We'll see if it ends up being more difficult than I think it is. Let's see, so this is tricky because my way just directly moves a single thing over rather than moving the entire thing over one at a time. Which means the left and right symbols can get kind of messed up. Oh, this is kind of weird, right? Because you can theoretically push a lot. Yeah, because like theoretically you can create like a pyramid and move everything at once almost. Interesting, interesting. Okay. So how can we account for that? We can keep track of what coordinates we're trying to push, I guess, right? So yeah, if thing is, I think left, right, we're fine. think left right is okay. If direction equal to order, because you can never push multiple things left or right. So copy basically all of this logic into here, right? Some layer of this is not right. What's going on? Where is this one? Oh, this one should be 1 over. Okay, cool. We do need to change this logic slightly, right? Let's actually just have it be a counter, I guess. So if some empty, we do while counter greater than 0, and then we want to just basically, how do we want to do this? We want grid so the robot has not moved yet, so we can do robot.x plus x's direction. Oh, no, we want something else. Okay, coordinate fake robot, because we don't want the robot to actually push that far. We just want something to act as this sort of force. So do fake robot dot x, fake robot dot y, plus this direction vector cool. So then we increment fake robot no more of that. What is 2 again? We don't need this anymore because it would have already gotten pushed in. But yeah, the original location of the thing should still be there. Actually, wait. Yeah. And then the robot still moves, but again, only 1 square, not all the way to the end. That might have been an interesting part too. What if like it goes opportunistically? But I guess that's not very difficult to do. 144. Ooh, that is bad. How in the world is that big? Yeah, I mean, I go out of bounds, which is quite a bad sign. Really shouldn't be going out of bounds. Why would you be going out of bounds? Am I maybe starting off too big because I'm doing counter plus plus at the top? Nope, that did not fix it. Well, that's not good. Okay, let's go to the smaller grid. Okay, right, still breaking. Oh, it's breaking for part 2. Okay. Yeah, it's not too surprising. I haven't coded the launching for part 2, so I guess it's not that. Okay. For part 1, let's see. So you go up. Yeah, that's good. Right. That is what's supposed to happen. If you go, oh no, you go left. Wait, what? This went, oh, it went left and went up, yeah. Wait, so left, yep, up, nothing, right. So left, nothing, Up, went up, up, nothing, right. You just ate it. You didn't even make a new one. That's not good. Let's bring the counter back to 1 maybe? Definitely shouldn't just be eating the box. Nope, you're still eating the box. Why would that be the case? Actually, what are all the X's anyways? Oh, I called it X. Oops. Should be dots, right? So this is, yeah, let's stick with the thing that they use. Yeah, but this move is quite bad. It just kind of eats the freaking next point. Should instead make it this. Wait, no, yeah, this should become this, right? Oh, not for the first one, because the first one is right. Okay, so the very first time it happened, we don't want to do that. So we actually would want, yeah, we can start the counter at -1. And then we actually want to start the fake robot as if it's already moved. So now when we push it, it still eats it. Dang. Should this not still be 0 then? Oh, you moved. So how is part 1 28,000 all of a sudden? What? Should be like tiny, right? Yeah, 28,000 is crazy. Especially because the grid actually looks right. Something else is wrong then. Wait, this is very confusing now. How in the world is... Because for part 1... Oh, wait. I'm controlling here as well. I gotta do new lines. Dot add. New line. Okay, but that doesn't explain anything else here, right? Like, why is part 1's value suddenly so massive? Should only ever take in... Huh? Yeah, it's only used in 3 places. It's the same 3 places. Grid shouldn't have changed in size at all for part 1. So why is this value 28,001? Huh? Like, what's going on here? Oh, I moved this. This is in the wrong layer. It was adding it at every single point, right? So now it should be good. 2028. Yep. Okay, cool. Nice. Okay, let's remove that print statement, unnecessary. And now we can turn this back on for part 2. Oh, well, that is not a good sign. Right. Because we got a couple more cases to add. So 3 and 4. So 3 is left bracket, 4 is right bracket. Okay, so we start. That looks correct. Right. Yeah, okay. Okay, this is the new example. We will try this. So we start with all right brackets. That's not good. Oh yeah, I know, because I'm copying from the wrong side. I should be copying, in this case, left to right, but I'm copying right to left. Got it, got it. Luckily, there is a pretty easy fix for that. In fact, it's going back to what I had before. We find the first empty cell. And we record that cell. Right, and then we actually go the opposite direction. So we want for m to equal the, yeah, like this. Like we flip the sign so it starts copying the other direction. And we can have these all subtract. I don't think that's quite right, but it should get us started at least. So now we push and they all vanish. What? Well, that is obviously not correct. They all vanish, huh? Huh. I would not have expected that. Oh, because I never changed these to first empty. Okay, that actually does make some sense. Alright, we're pushing boxes. Nice, yep, look, does, well, nothing's really moving. Left, down. Oh, I haven't implemented down or up yet. Yep, okay, that makes sense. So we can have an else here. So now we work on down and up. So again, I think the first part honestly is actually pretty trivial both ways. Like if it's just fine, then it's fine, right? Like if it's about to run into a wall or if it's an empty space, just let it go. Cool. Now though, we have to deal with the case where we have to sort of move things vertically. Okay, so how do we do that? So it's not quite as easy as just first empty, because basically I think what we have to do, we have to track basically all the indices that we care about. So obviously at the beginning we only care about the robots, right? But then we have to sort of find the point where we get all empties, right? So first empty is kind of the same concept, right? Except now we actually probably want this to be an int. And we want there to be an all empty. And sure, counter is fine. So we increment counter, right? But now we actually need to look for every single possible square. So we do for int index in indices. We construct this goal. So I need to think this through for a second. So x's are that way, y's are that direction. So we want to increment let's just do, let's start at the robot level, right? So we increment, we go level plus plus as well to get to the correct level, and then for our next index we check, we do these checks, right? So all empty equals true. Actually, we can do probably just not, while not all empty. All empty equals true, and then if grid index and then level equals this, we just break. Oh, no, we need to... Actually, this just means we can just return, right? Because nothing happens after that point. Like, if pushing wood causes it to hit a wall, we don't do anything. Otherwise, if it's not equal to 1, then we gotta figure out what to do in this case, right? So we want all empty equals false, but then also if grid index level is 3, that means we need to add in like the next set, right? So each time we sort of refresh what indices are available. Next indices dot add. So we're gonna add we can do we can just add those all in. So now if it's 3, we need to add 4, which is the +1. So we do index +1. On the other hand, if it's 4, then we need to add index -1. Right, and then we're gonna do indices equals, well, okay, if but this just tells us if we can move it or not, right? So now we have if, well, we know all empty has to be true because otherwise it's already returned, right? So we don't actually need to special case that. I'm wondering if I should just have a list of lists instead, right? Like keep track at each stage of which ones need to be moved. That way at the end we can just use that sort of big list. Yeah, I like that idea. I'm going to turn this into a list of lists. So we can do indices dot add new array list, and then indices dot get 0 dot add. So now we have that. So we get the previous one, and then we do indices dot add next indices. Okay, so now we have like a very large list of indices that we're tracking, which is good. Right, so we start with just the robot. Nice. Then the next level will be all the boxes that we're pushing, which is at least 1, right? Because otherwise, if there's no box in front of us, that means it's either a wall or an empty space, which we've already exited from, right? Return. So you know there's definitely a box above us, right? So, and then if there's any space, oh, there should be index level. Oh, and this should be plus equals y's direction, because we don't want to be going the wrong direction here. Okay. And then if we make it all the way down here, let's print out just to make sure that the logic generally holds. Okay, so let's see. We have here, goes down, goes over, can push, goes over, can push. Cool, okay, so it looks correct, like, at least right now. Now, you know, it's hard to know for sure. But as it stands, it looks fine. Okay, so this means if we are actually able to make it to that point, right, then we need to go through all of the indices. Well, not all of them. I think probably not the very last layer, maybe. Wait, what? Oh, no indices. Oh, am I one? I'm one layer out. Okay. Yeah, there we go. So dot size -1. We want to start at the top again. We want to fill in the proper direction. Greater than. I'm going to start with greater than equals 0. It might be greater than 0. We will see. So we want list integer. Indices layer equals indices dot get I. Okay, so now for everything at this layer, right? We want basically to do for index in indices layer grid index comma layer robot dot y plus I times y's direction equals let's see, so the index part must stay the same, but this I think goes which way? I -1 direction maybe? Okay, let's see how that looks. Probably not right, but hey, worth a shot. So it goes over, goes down, goes over, push. Did not push anything. Okay. Why did it not push? I mean, there's the obvious part, right? Like, robot.x plus equals x's direction, robot.y plus equals y's direction. But we're not moving, and we should be moving. Yeah, you see, I'm just eating into it, which is sort of not how this is supposed to work. Like, why is this not changing the grid? Like, what is... I mean, these are different coordinates, so something should be getting manipulated, right? But it looks like nothing here. Moving... index... 2... I don't know if it's going up or down, which is why I don't want to hard code, and that's why I'm using y's direction. Oh, that's not good. Oh, because up down is x's, not y's. Oh, that's bad. Okay, so I actually want to do, this is dot y. Yeah, I'm not surprised I'm running out of heap space. Oops. Right, and level is plus x's direction. So this should be index level, right? then this needs to get flipped as well. This is index. This is robot.x plus I times x's direction. And then this needs to be index. And this is I minus 1. Okay, so now let's try this. Okay. I didn't even bother trying to push it this time. It's not good. Why did you not bother to push? We can get rid of the counter variable also at this point. So we start on the robots level. We increment level. Check if there's anything there. Right, so let's do this. System checking level. Just to see what levels we're trying to check at this point. So it's checking level 6. 0, 1, 2, 3, 4, 5, 6. That's... does it try to move down at one stage? No, it never tries to move down. So why would... It's a bit odd, right? Should be the other direction. I didn't flip my positives and negatives though. I mean, this part... Oh. Wait, what? 908. Wait, when did I break... Huh? Oh, right, because it's a bit different. Oh, these are also different as well. This box, the closest edge, 0, 1, 2, 3, 4, 5. Okay. So that's actually good to note as well. Wait, let me actually add that in before I forget and turn in the wrong answer. So, or 3, but not 4 specifically. Okay. Yeah, it's a bit strange, huh? Oh, 6. Could be this way as well. 0, 1, 2, 3, 4, 5, 6. Ugh. That's not right either. Okay, wait. We know it's 0 or 1. So if the direction is 0 or 1, yeah, we're moving in the x plane? Is that correct though? Yeah, the x plane, right. So we're getting up, so direction equals 1, which is negative 1. Right, so layer, how is the 0, 1, 2, 3, 4, 5? Yeah, what is going on here? Because shouldn't the direction be negative 1 at this stage? Am I looking at the wrong place? Yeah, no, the layer is negative 1. Okay, awesome. So I'm closing this logic. Yeah. So x's direction is -1. Yeah. So how is level 6? Right, like robot is at 0, 1, 2, 3, 4, 5. And like, is robot somewhere not where I think it is? Oh, I did robot.y, not robot.x. That would do it. Okay. That's on me. Level 7 is out of bounds. It's quite unfortunate. Alright, this should be what? Level index? No, I didn't really want to do debug mode, but it's fine. Yeah, something's gone wrong here. Let's see what it is. Yep. So it's moving a bunch of stuff. Oh, it actually... I mean, it moved correctly, except it... Right, okay. So we need to set grid... No, we can just actually remove this, right? Okay, that's good, that's good. That's not good. Why did you copy? Oh? Yeah, that's quite bad. Oof. Okay. Some copying thing is going awry here. Like it's supposed to copy these two up to these two, which is good. But then why did it copy... Oh, copied these two up to here, which is bad. Oh, in this case we do actually want to go the opposite. We want to push these up because it's not the same amount of tiles. Right, so we actually want to do what, robot? Oh, my brain kind of hurts. Let's see. So we're one level too high right now, right? Because we are adding the level where everything is free at the end. So let's not do that. If not all FD. And then what we can do is do I plus 1 equals the I of this. This print line is now inaccurate, so let's not use inaccurate print lines. Oh, that is way worse. So it copies that properly. Oh, right, because it doesn't delete the old version of itself. That's fine. We can just do that. Oh, that looks pretty decent. Okay. Yeah, you know what? Let's just go for it. If this doesn't work, we oh goodness, I forgot to remove the print statements again. Oops. What? Probably. This feels wrong. Let's put it in and then we'll debug why it's wrong. Yeah. Okay. What is this? The sum in the scaled up version of the larger example from above. Let's find that larger example from above. Here, cool. Let's start with this, see what's going on. 7780. Yeah, that's not right. And let's actually just undo the print stuff. Also, we gotta stop printing there. That's kind of useless. Okay, so in the final version, it looks like, oh my goodness, it looks nothing like what I have. Okay. That's quite bad. So it's not just like a GPS calculation error. I'm actually doing something very wrong. What is going on? Okay, well, let's just go through the moves and see if I can spot anything obviously wrong. Actually, the good check is if part 1 is still correct. Make sure I haven't messed up something fundamental here. My goodness. There's a lot of printing. 10,092, is that right? It is. Okay, cool. So part 1 is fine. Let's look at part 2. Let's have that starting grid. Starting grid looks reasonable. Yep, looks reasonable. So we go left. We did not go left. What? Huh? Oh, this is after we already went left? Oh yeah, we already went left. Then we go down. Yep, we go down. Yep, looks good. We go right. Okay, looks good. We go up. Looks good. We go, what is it? Sorry, right. Wait, where were we? Right, up, left, down. Left, down. Oh, what? I went left again. Huh? Okay, I'm getting lost. Let's do this. So it went left. Right, we clearly got pushed something. Then went down, down. So down, down. Yep. Then it went right, up, right. Yep. Up. Yep. Then it went left, down, left, down. Yep. Then it went up. Yep. And then right. Yep. And then it went down, right. Down, right. Okay, still looking good. Then it went up, down, yeah, nothing changed. Then it went down, up, nothing changes there either. Yep. So up, down, down, up, down, right, down, right. Yep, nope, still looks good. Down, left, down doesn't move it, left, looking good. Right, down, yep, no movement. Up, down, up. Uh-oh, we just dropped a box. Where did that box go? Hello? Well, that's where it went wrong. Yeah, that blows. We just dropped a box. What happened there? I mean, we hit the all empty case. It's supposed to project itself up, right? But it never did. Huh. Okay. Not great. What if we remove you? Oh no, things are horrendously wrong if I remove you. Yeah, okay, definitely not the solution. Oh, this is quite strange, right? Like, maybe I should just take a simple case like that. So we have, yeah, okay, I'm gonna make U an O, U and O, and just literally have a single move, which is up. Yeah, okay, it does delete itself. Very bad. But good that I can reproduce it consistently at least. So what could be going wrong in here? We have the level. It has just a robot initially. Here, how about this? Let's print out what indices looks like at this stage. So 8. Yep. 8, 9. 8, 9, 9, 8. Okay. I mean, the extra 9, 8 shouldn't really matter, right? Like maybe it should have been a set, but why would the extra 9, 8 matter? Oh, because it it does matter. Dang it. Okay. Let's do a set. Oh, what did I just do? Oh yeah. And then we do set. Doesn't really change that much. Oh no, something's broken. Set hash set. Ah, cool, that worked. Okay. Let's just go all the way back. So much nonsense. Yeah, back to here. This print's gonna take a billion years. Set to here. No, I always get that one off, huh? Not great. Okay, that's a different answer. Nope, still wrong. Okay, well, let's do the example again then. Nope, not paste. Control Shift Z. There we go. Go to U. Turn U back live. What you looking like at the end? It's supposed to look like that, and it looks like, oh boy, it's still wrong. Okay, so maybe that's not the only case I had to fix. Actually, let's check if part 1 is still right. Like, did my fix to part 2 break parts of part 1? Shouldn't, right? Okay, yeah. Alright, back to here we go. So we go left, down. Sorry, what? Left, down, down, right, up, left. Yeah. Now we go down, up, right, down, up, right, down, right, down. Yep. Right, up, right, up. Yep. Down, down, down. Yep. Up, down. Down, down, up, down. Yep. Right, down, right, down. Yep. Left, right, left, right. Yep. Down, up, down, up. Okay, that looks correct, right? Yep, correct. Down, left, down, left. Yep. Down, left, down, left. Yep. Up, down, yep. Down, left, left, left. Down, left, left, left. Okay, looks good. Up, Up looks good. Up, right, yep. Left, left, right. Left, left, right, yep. Left, right, right. Left, right, right, yep. Down, left, down, down. Down, left, down, down, down. Yep, looks good. Left, right, uh-huh. Up, down, yep. Up, right, yep. Up, left, left, left. Up, left, 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 yep. Right, left, yep. Left, down, yep. Left, 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 down. Left, 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 down, yep. Up, down, down, up. Up, down, down, up. Down, right, up. Down, right, up. Okay, that's not good. I mean, we went through the entire first row with no issues, which makes it a bit surprising that somehow we don't get to where we're supposed to get. Yeah, very strange. Nothing that seems overtly wrong. Sorry, I'm just scrolling through right now. That's what I'm not talking. I'm trying to see if there's anything it does that looks weird. Like if there's any weird like brackets that shouldn't belong. But I'm not seeing anything. I mean, this looks all correct. Just, yeah, it's not really doing much, but I don't see anything it's doing wrong either. Yeah, I'm not sure. I am not sure. There's too many instructions to easily go through one by one, unfortunately. But my warehouse definitely does not look like that. It's very far from looking like that, actually. Which is strange. The list of movements does not change. The robot does not change in size. Yep. Okay, wait. Let's run this example again. Make sure I didn't break anything here. No, it looks totally fine. Right. That's exactly what the end state should be. Yep, that is indeed what the end state should be. Okay, well that's not good, because that means, so this simple example succeeds. This one fails for some reason that I cannot determine, which is always a bit of a scary sign. Right, like, definitely not great. Yeah, I don't know. I don't know why it's failing where it is. Very, very strange. Let's see. Wait 1 second. I'm gonna go to the end. So the left side, this all look right. That somehow a lot of things that should have gotten pushed to the left ended up on the right. Which is odd. Actually, you know what's weird? There's 2 at the bottom here, but there's 3 at the bottom here. Something about that doesn't seem to jive. And obviously it starts with 1 at the bottom, right? But I don't know how to investigate any of that. Like if I had 3 at the bottom and there should have been 2, then then it's obvious. I just need to figure out when the third one gets to the bottom. But with 2 at the bottom instead of 3, I don't really know how to debug why it didn't move the way it did, right? Like that seems quite difficult to debug. But yeah, no, I mean, I'm just taking a quick look again, but none of the moves seem off. Yeah, all the moves seem quite reasonable. One thing I could do is run this, but only for cases here. This way this only runs for the critical scenarios. Okay, it didn't run at all. What? Huh? Oh no, it is running, sorry. So we push here, yep. Oh yeah, so let's see. Pushed up. We pushed it up, yep. We pushed it up, yep. Pushed it up again, cool. Pushed it up again, seems reasonable. Kept pushing it up, okay. That's how it ended up in the corner, which doesn't violate anything. I do see 2 in the corner. Then push those down, cool. Yeah, I see, like this side is mostly as expected. I then pushed that one down, okay. Then went over here, pushed this one down. Okay. Oh yeah, I don't know. Like this just looks. It looks the exact. It looks right. Yeah, but I mean, I've already tried this. I mean, let's just do a quick check. There's no double lefts. There's no double rights, right? Okay. I mean, the walls seem to be where they should be. Oh man, yeah, I am quite stumped here. Like, I feel like my algorithm is correct. Obviously something's wrong given it's not working, but there's nothing that seems crazy off to me. I guess maybe I can try another case. Let's do sort of, let's try this case, I guess, but slightly more complicated maybe. So let's also add in another layer here. Right, so then I can go, let's go left, left, down, down, left, left, up, something like that. How does that look? Right, nothing moves. How about there? That looks good. That sure looks good. Okay, what about if you are a dog? Nope, that looks fine too. What if you are like this? And it doesn't move, which is correct. What if it's like this? Oh no, that one's bad. It should have moved. Oh, I can't just add in everything from the previous row. That's what's going wrong. Right, because I'm doing an add all here, which is not actually correct. I can't just assume that every row automatically has the previous row in it. Oh boy. Okay, that's quite bad. What's going on here? I was hoping to just yeah, if it pushes up, right, against the left, it should add in on the left. What in the world? Oh, it should add both. It should add itself as well, right? Aha. Okay, that looks better. Now if we go back, right, to the example case. How do you look? Oh ho! That looks quite close. Yeah, in fact, it looks identical. Close might not be the right term. Yeah, I'll keep the prints in. We just gotta deal with it. It'll finish eventually. Ah, okay. Nice. I mean, a relatively good part one by me, but yeah, the part two was a bit tricky. I probably should have been able to realize the faulty assumption, but it happens that none of the examples had it, and I wasn't thinking about it too clearly. But yeah, I mean, I don't know. It's a bit of a scary sign going into, the sort of fabled day 16, which is I think when a lot of past years have gotten pretty hard. But hey, looking forward to doing the more difficult days as well. See you guys tomorrow.